Good afternoon. This is chemical bonding part 3. We're going to talk about the two types of bonding. We began mentioning these in the very first page of notes that we handed out, ionic and covalent bonding. But now we're going to get into great detail about what each one of those things mean, what each one is. Ionic bonding is when one or more electrons from one atom is transferred to another atom. So one atom will give up an electron and another atom or element will gain that electron. So you can see in the case here of sodium, sodium has one valence electron. Remember that the octet rule says everything wants to have 8 valence electrons. So if sodium gave up its one valence electron, it would have 1, 2, 3, 4, 5, 6, 7, 8. So it would be obeying that octet rule. So it wants to give up this electron. Chlorine, on the other hand, has 7 valence electrons. In order to obey the octet rule for chlorine, it really wants to gain another electron. If it gained another electron, it would have 1, 2, 3, 4, 5, 6, 7, and then that one would be 8. So what happens is the sodium will give up its electron. You see down here, it doesn't have that one valence electron anymore. It gives it up to the chlorine. Chlorine now has 8, sodium now has 8, and they are obeying that octet rule. When that happens, we have two charged particles. They are not neutral atoms anymore. Since this chlorine has one less electron, it has a positive charge. Okay, remember that sodium has 11 protons. Okay, 11 positive charges. Because that's the identity of sodium. It has 11 protons because its atomic number is 11. But now it only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So if we think of this as the same way we add sign numbers, 11 plus a negative 10 gives me a positive 1 charge. So that's why the sodium has a plus sign beside it, because it has a positive 1 charge. Over here, chlorine. Chlorine, by definition, is atomic number 17. It has 17 protons. But now it has gained 1 electron from the sodium, so it now has 18 electrons. So 17 plus a negative 18 is a negative 1 charge. So that's why the chlorine has a negative sign beside it. If something gains electrons, it's going to have a negative charge. If something loses electrons, it's going to have a positive charge. Okay? This is just another diagram showing you how electrons can be gained or lost. Okay, here's another diagram. It's just a different way of saying the same thing. You have sodium. Sodium gives up its electron to chlorine. Now, sodium has 1 less electron, so it has a positive charge. Chlorine has 1 more, so it has a negative charge. If we take a look at the one for magnesium, this is a little bit, it looks strange on mine because you can't see the other electrons, so I'm going to draw that one in there. We'll say we have 2 electrons on this side. It's probably actually on the other side. Both of those electrons are going to be given up to the oxygen. So then oxygen will have 8 electrons. Magnesium will be short 2 electrons. It lost 2 electrons. That means it has a plus 2 charge. If we scroll, there we go. Now we can see those a little bit better. So I'm going to take that one off. If we look at calcium here, calcium again wants to give up 2 electrons. Chlorine only needs 1 though. So in order for calcium to give up both of its electrons, it's going to have to give it to 2 chlorines because each chlorine can only hold 1 more electron. Remember that octet rule, magic number is 8 electrons. So calcium gives up 1 to chlorine. That's going to give me 1, 2, 3, 4, 5, 6, 7, 8. It still has one more that it wants to get rid of. So it will get rid of that one more to a second chlorine atom. Again, since it gave up 2 electrons, it will have a positive 2 charge. And each of these chlorines will have a negative 1 charge because each one gained 1 electron. Oxygen up here has a negative 2 charge because it gained 2 electrons. Covalent bonding is just the opposite. Instead of one electron giving up, or one atom giving up an electron and another atom gaining an electron, in covalent bonding, the two atoms will share one or more pairs of electrons. Remember, pairs means 2. So we talk about pairs of electrons, we're talking about 2 electrons. The electrons spend more time between the two atoms than isolated on one atom or the other. So they get shared between them. Here's an example. Hydrogen, remember, has only 1 valence electron. It would like to have 2. It's the exception to the octet rule, and it would like to have 1 more. Oxygen has 6. Oxygen normally has 6 electrons, valence electrons. It would like to have 2 more. So what you're going to have is 2 of the hydrogens sharing their electron with the oxygen. They don't necessarily give it up, they share it. So that's why we stick those 2 dots in between the atoms rather than moving that dot completely from one atom to another. It's shared between the two, as you see here, because it's not oxygen's electron anymore and it's not hydrogen's electron anymore. They share those 2 electrons. And that's covalent bonding, when you share between the 2. Here's another example. Hydrogen would like to has 1, it would like to have 1 more. This second hydrogen has 1, it would like to have 1 more. If they can get together and share their 2, they will have that full octet that hydrogen wants to have. It wants to share 2. And what we do, just as a convention, is we replace these 2 dots with a dashed line. That dashed line means 2 electrons. So if we look at chlorine, chlorine has 7, but it would like to have 8. So this chlorine can share an electron with that chlorine, and then this chlorine shares with the first chlorine, they wind up sharing 2 pairs of electrons, or 2 electrons, 1 pair of electrons, and that gives each one of them 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. It has this one has an octet. And then if I come over here and look at the first one, 1, 2, 3, 4, 5, 6, 7, 8. This one has an octet. Each one has 8 electrons. That makes them stable, and so they're going to share those 2 electrons between them. So that's why we draw the dashed lines. This is just a third example. Hydrogen has 1 electron, it would like to have 2. Chlorine has 1, it wants to have 8. So the hydrogen will share its electron with chlorine, and then the chlorine will turn around and share its electron with hydrogen. That means they're sharing a pair of electrons. Each atom has the full shell that it wants to have, and so you form that bond. That sharing of 2 electrons is represented by the dashed line. These extra electrons that are around the chlorine that are not involved in the bond, those are called lone pairs. The electrons that are actually involved in the bond are called bonding pairs. Covalent bonds. Now with covalent bonds, we have something that's called polar covalent. And polar covalent bonds are an unequal sharing of electrons, where hydrogen doesn't want as much of its electron as oxygen does. Oxygen wants to keep more of its electrons. It's more electronegative. It really, really, really wants those electrons. Hydrogen, not so much. So hydrogen will donate more of its electron pair to oxygen than oxygen will donate to hydrogen. It's an unequal sharing. Kind of like a tug of war. If you have a larger side of tug of war, they're going to have more of the rope than the smaller side of the tug of war team. So that is an unequal sharing, and we call those polar covalent bonds. Since the oxygen has more of the electron, it has more of a negative charge. But it's not a complete negative charge, so we represent that with the little funny looking D called a delta. It has a partial negative charge right there because it's got more of that electron closer to it. The hydrogen has this partial positive charge, which we represent with that little funny looking D, because it has less of the electron. Metallic bonding is, again, just like the name implies, it's between metals. It's the bond between metals, and it's very unique in that the electrons are not attached to one particular atom. Rather, they are spread out equally throughout the whole piece of metal. And this is what accounts for metal's properties. It makes it shiny. It makes it easy to conduct electricity because these electrons are just kind of sitting on top. And electricity is the flow of electrons. So it makes it very easy to conduct electricity. It makes it shiny. It makes it malleable because those electrons are able to just slide past each other and move wherever they need to move when the hammer hits it or you're drawing it out into a wire. So metallic bonds are just between metals, and rather than the electron being attached to one particular atom, it's kind of spread out throughout the whole thing. The last type of bonding we're going to talk about is hydrogen bonding, and this is very, very important because water makes up such a huge part of our life. Hydrogen bonding is something that we experience all the time. And hydrogen bonding, just like the name sounds, is between hydrogen and several other atoms or elements. Hydrogen and oxygen, hydrogen, and there's a whole list. But the most common one, so hydrogen bonding is between hydrogen and oxygen. And what happens is the hydrogen, again, because it's less electronegative, has that little partial positive charge. And this oxygen, because it's more electronegative, has a little negative charge to it. And they form an attraction between each other. And it forms a very strong bond and gives water some of the unique properties that it has. And that's hydrogen bonding. Just exists between the hydrogen atom of one molecule and the oxygen atom of another molecule. So hydrogen atom of one molecule, the oxygen atom of another molecule. And it's what we call an intermolecular force because it is between two separate molecules, and it's what holds those two, forms an interaction between those two molecules. Hydrogen bonding is important, of course, in giving water the properties it has, but it's also important in proteins and the nucleic acids that are used to make up proteins. hydrogen bonding plays a very key part in what the properties that those compounds have. Okay, and that's it. If you have any questions, make sure you bring them to class tomorrow, and have a great day.